start the recording also. Okay. Okay, this is the transfer function what I have. So let us start solving or start writing the root setup for this. SQ is there, no? Do you have SQ? No, no, I don't want complete zero. The first element should be zero. Okay, this is where the complete row becomes zero. So then, no, no, you will end up with the auxiliary equation and so on, so no. I don't want that. I want where you have only one element of the roots are becoming zero. So yesterday we had this problem, no? Something like this. I'm just looking. Yeah, just tell me that. I think this you can solve. This can be solved. Tell me that. Okay, then it is s power 7 plus 5 s 6, and then 9 s power 5 plus 9 s to the power of 4 plus 4 s cube plus 20 s square plus 36s plus 36 equal to 0. Am I correct? Again, just for information, this topic is also included in the test. So if you are thinking, okay, then so this is there included in the test. So what we do till today, till 12 o'clock or 12:30, so it is there for the quiz or the test. Then you'll be more attentive. Will you be? Yes, for 6. So shall I write this? This is 1, 9, 4, 36. Am I correct? Then it is 5, 9, 5, 9, and then 20, 36. Am I correct? Just help me to get this. What is 5 into 9 minus, I think it is 4 into 9 is 36 by 5. Give me the direct value, one of you. Okay, this is 7.2. And then this is 9 into 4, 20, 20. Okay, here it becomes 0, correct? And then this becomes, this is 30. How much is this? This is 28.8. Then S per 4, first one is this into this minus this. This will be 9. 9. No, 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 not the second term. Okay, let us continue with this. Now I want to have the first element should be 0. If the first element is 0, then we have a separate case. Okay, shall we continue this? So this is 9, this into this. I think this we can solve. Okay, we shall continue with this. This into this by minus 0 divided by 7.2 is 9. And then 7.2 to 20 minus this into, give me this. There are so many students, you can just work it out, no? So I have 40 students, including me. I don't have, of course, I have the calci. I can also do the calculation. So I can also be a student along with you people. That I can do. Where is my calci? Okay. 5.1c. First element should be 0. I think this is, you can solve it. So there is nothing great in this. So let me just go to 5.1c. Is it S per 5? This is 5. This S per 5 plus S per 4 plus 2s cube plus 2s square plus 3s plus 5 equal to 0. So then this becomes S per 5 is for 4, 3. Okay, this is 1, 2, 3, 1, 2, 5. Then this becomes 0. Then this becomes how much? 1 into -2, -2, this is 0, correct? Okay, in such case, we cannot continue. We cannot continue because the subsequent terms will become infinity. In such case, you have to replace s by some, okay, z minus 1, z to the power minus 1. Meaning, so let us replace, then this will become 1 over z to the power of 5 plus 1 over z to the power of 4 plus 2 by z to the power 3 cube. Then it is 2 by z square plus 3 by z plus 5 equal to 0. Correct? Take the LCM, then this will become 5z to the power of 5 plus 3z to the power of 4 plus 2z cube plus 2z square plus z plus 1 equal to 0. We are now, whenever you end up with a roots array where the first element of a particular row becomes 0, you replace the s by 1 over z. When you're replacing s by 1 over z, this is a modified characteristic equation. You rewrite the characteristic equation, then the powers will simply interchange. The quotients of s power 5 will become the quotient of z to the power 0. So this is your new characteristic equation. Now you solve for this. Shall we solve for this now? Will you solve for this? Z power 5. So z power 4. Then this becomes 5, 2, 1, 3, 2, 1. Is it now minus 4 by 3? Minus 4 by 3, then it is, then this into this minus this into this. Give me the, it's plus 1 by 4. Okay, this is 1 by 4. Then here it is, I think, 0. Z power, no, it's not 0. Okay, this into this, okay, it is 1. It is 1, 0. Then here this is Z. This into this minus this into this by 1 by 4. 7 by 6, 0, 0. Then it is 1. Correct? Two sign changes. System is unstable because there are two poles onto the right hand side of S plane. When I say poles, closed loop poles. Closed loop poles. Fine. Okay, this is one special category when you end up with only one term or the first element of a row becoming 0, you simply replace the s by 1 over z. You rewrite the characteristic equation, rewrite the roots array, solve for it, we'll get it. And when you are rewriting, you'll not again end up with something like this. If you again end up with, okay, it will not happen. So that type of problem will not be there. That type of situation won't come here. Anything? Okay, now we'll just see this problem. Let's have a look at this. Or let me just try to introduce that. Okay, before I introduce 20 sim, let me see. This is 4K, 2s plus 1. I have this 20 by s plus 1 This is 0.2. This is minus. I have one more block, which is 0.05 divided by 4s plus 1. This is having a feedback minus. This is RFS, CFS. The question is find the value of K so that system is stable. For the system to be stable, what is the value of K? There is a system given by this type of block diagram. You're asked to find the value of K so that system is stable. How do you proceed? What is required to know the stability of a system? Actually, what we need is characteristic equation. So how do we get the characteristic equation? If you can able to get the closed loop transfer function, the denominator of the closed loop transfer function itself is the characteristic equation. Correct? So let us first find CFS by RFS. Correct? Uh, Looking at this, can we write the characteristic equation or the closed loop transfer function? Uh, like okay, if you want to write it using a signal flow graph, this is a forward path. You have one loop, you have second loop. Correct? Is it 4k divided by 2s plus 1 into 20 divided by s plus 1? This is like okay, forward path divided by one of the loop is 1 plus, this is minus is there, so it will be plus. So then it will become 4 divided by s plus 1. This is the loop gain. Am I correct? 20 into zero point 0.2 is 4 plus how much is this? So this is 80k divided by 2s plus 1 into s plus 1 multiplied by 0.05 4s plus 1. Am I correct? So shall we solve for this now? So it will be now, okay, it will be 80k. What will be your equation? Will it be 2s plus 1 into s plus 1 into 4s plus 1 plus of 4 2s plus 1 into 4s plus 1 multiplied by how much is 18 to 0.05? Will it be 4 4k? Then will it become 4s plus 1? Am I correct? This is actually okay. Plus wait. Where s plus 1 whole square? 2s plus 1 it is wait plus, am I correct? Okay, the whole idea is this is your CFS bar FS. Am I correct? Hello. If you are asked to find the value of K for this, you have to write what is CFS bar FS. CFS bar FS is getting the transfer function for this one. what we are writing is we are writing the forward path, which is this is like okay, writing the forward path from here to here is 4k divided by 2s plus 1 multiplied by 20 by s plus 1. This is what is P1. 1 plus one of the loop, second loop. Of course, both the loops are touching each other. There is no product of it. Now you are trying to solve that. You are trying to simplify that. Then you'll get this x by some value by 1 plus g of s into h of s. Am I correct? This you get it in the form of s power n plus s power so on so. So once you have the characteristic equation, solve for it. Once you have the because this is the characteristic equation. Equate this to zero, you'll get an expression. Because this is purely mathematics. So there is no much control system involved here when you're trying to find its what equation. So once you're done with this, write the roots array. You will certainly end up with an auxiliary equation. You will certainly end up with an auxiliary equation. Look for the value of k where the system is stable. So then, of course, it will be of something like this type, the one what we had it like this. This may not be of S4. What is the order of the system here? I think the order of the system is 3. This is S cube you'll get. So you'll get third order system, and I think maybe the third row you'll have all zeros for a particular value of k. So then you can see the value of k has to be more than that, so that system is stable. I hope you can do this. So then I just try to move on to some other question. So where I have something like this here. So I have a system which is GFS into HFS is given by K into S plus 13 S into S plus 3 S plus 7. Correct? You also find the value of K greater than 0 for system to be stable. So now let us introduce the 20 sim and try to understand okay what happens. Okay, what is this is GFS into HFS. What is CFS bar of S? Is it actually GFS by 1 plus GFS into HFS? What is characteristic equation? Is this your characteristic equation? 1 plus GFS into HFS. You have GFS into HFS, add 1 to it and equate to 0. Correct? That is 1 plus K into S plus 13 divided by S into S plus 3 into S plus 7 equal to 0. Then this becomes K or S into S plus 3 into S plus 7 plus K into S plus 13 equal to 0 is your characteristic equation. Actually, this plus this is characteristic equation. Uh, can we actually solve for this? Can we actually get the polynomial? It is actually S into S plus 3 S plus 7 plus K into S plus 13 equal to 0. Is it S square plus 3S into S plus 7 plus K plus 13K. Then it is S cube plus 7S square plus 3S square plus 21S KS plus 13K. So then the equation is at S cube plus 10S square plus 21 plus K into S plus 13K equal to 0. So shall we write the roots array for this? Is it 1 21 plus k, is it 10? If no, can you able to solve this? Can you solve using your calci? If no, if it is a very simple third order equation, you can go ahead because you have a k here, no? Since you have a k, you need to go for root 7. If it was something like if you had some 25 here, then you would have used your calculator and you would have found out the values. Now you are asked to find the value of k for the system to be stable. So why I said okay, you need to have an order of more than three is because your calculus can comfortably give can solve the roots if the order is till three. Even though the order is three here, but you are stuck with the values of coefficients of all s. Correct? Okay. Then how much is this? 10 into 21 plus k minus 13k divided by 10, then 0, 13k, 0. Am I correct? Can we actually solve this now here? What is it 10 into 21 plus k minus 13k if it is 0, then is it 210k minus, sorry, 210 minus 3k equal to, correct? Is k is equal to 70 or is it k margin now? Why it is k margin? Because you are equating this to 0. When you equate this to 0, then the k becomes immediately k margin. So now, what happens if the value of k is greater than 70? This term is negative. What does it mean? Meaning there are two poles to the right of the S-plane, system is unstable. If k is 70, oscillatory with what frequency? With a frequency equal to, now it will be, what is EFS? EFS is equal to 10 S square plus 13k margin. It is 10 S square is equal to minus 13 into 70. Correct? How much is S square? Minus 13 into 7. Correct? How much is S now? Plus or minus J root of this. Is it overall? 8, 8.26. So roots are plus or minus J 8.26 radian. That is, it will going to oscillate with the frequency of 8.26 radian per second. Okay, we shall do this now. So what I do is, we started with this one. No? We started with this. So let me introduce 20 sim to you people. Where is 20 sim? 20 sim. Let me just open 20 sim. Okay, let me share this to you and then. I hope you people can see this 20 sim. Is it visible? Okay, now in this 20 sim, we can able to simulate all this stuff. Okay, whatever we are discussing now. Okay, let us first go to this insert submodel. In this submodel, you have to go for linear systems. See here, this is the flow. Insert submodel linear system. Just note down this on the insert menu, submodel option. In that submodel option, it's linear system. If you click on linear system, you'll get this window where you can edit the poles and zeros or the transfer function. See here. So what is the poles and zeros you have? If you can just see the, okay, let me just show you this. Is this camera visible now? Okay, where are the poles now? Poles are at origin, -3, -7, and at -13 you have a 0. Shall I go to this and then edit those things? I will go to poles and zeros and gain, edit. So there is by default so many things. So I will add, do you have a pole at origin? Because there is a S term in the denominator. It has been added. Do you have a pole at -3? That is S plus 3 corresponds to a pole at -3 in S plane. Do you have one more pole at -7? Can you able to see I'm adding those poles and zeros, correct? Can you see there are three poles, one at origin, one at -3, one at -7. These are all real, imaginary parts are 0. So where is 0? Do you have a 0 also? You have a 0 at -13, correct? Shall I add? Okay, done. It's done. I will apply and say, okay, done. Okay, let us see the poles and zeros. Can you see now here? There is a pole at origin. See here, this is origin. There is a pole at -3. See, this is -2, -2, -4, -6. It's going like that. And there is a pole at -2. There is a pole at -7. And there is a 0. You can see there is a circle here at -13. At -13. Correct? Next, we need to see. Uh, so what I do, I will just have this. Now you can see this is the next topic what we'll be discussing. We call it as root locus. Root locus is an extension of your what poles and zeros, whatever you're talking about. Now we know there is a k term in your equation, correct? There is a value of k. So maybe in initial classes, I think if I just go back to my earlier classes, can you see here? This was the transfer function as the value of k was keep on changing. Can you see the closed loop pole was keep moving from one point to other point? It was initially at -2, -3 when the value of k is equal to 0. As per this, when the value of k changes, they have started moving. That's exactly, this is what does the roots or keep changing their path or keep changing their position. Now, what does this root locus means is it's a locus which is tracing the path of the roots as the value of k changes. As the value of k goes above 0, that is, if the value of k is between 0 and infinity, the poles will change their position. Poles matlab roots of the characteristic equation. Then how does those roots move? Because here you are giving absolute values, like 0, 0.1, 10, 1, so on and so. Suppose if you keep on giving from 0, 0.1, 0.2, 0.3, 0.4, very infinitesimally very small values of k, can you see this is taking different values? Meaning that roots will have a path. The path traced by that locus is called as root locus. As the root is nothing but this characteristic equation roots. The path traced by the closed loop path is nothing but, or closed loop poles is nothing but root locus. Let me just go here. See here, can you see the path here? I can actually trace the value of k also. See here. Can you see? Can I just See the value of k here. K is 0. See here is this is my arrow. This is my arrow. See now, as the value of as I just move this position, can you see the value of k is increasing? Can you see if I further increase the value of k? Can you see that arrow started moving? Along with that arrow, can you see these dots? This dot. Can you see one more dot here? Suppose if I move this, suppose if I move this further, if I move this further, are they coming here? Can you see if I further increase it, will they collide? They are colliding. And if I further increase, are they becoming complex? Can you see the real and imaginary parts here of the roots? If I further increase, can you see where are all the, how many poles are there in this characteristic equation in this system? It's a third order system. So this arrow, this dot, and this dot are the indication of three closed loop poles. If I further increase, are all the poles to the left half of the S plane now? This is your S plane. You can see this is zero. This is origin here. So this is left half and this is right half. If I further increase, can you see it is still increasing? See that? Is it still there to the right? Sorry, left. Suppose when this value k becomes 70, they are on the imaginary axis. That's what we actually found in from my calculation. So in the calculation, we found that at k is equal to 70, system will be oscillatory. System will be oscillatory. I can increase the value of k. I can increase the value of k and see that. Can you see it's almost 74? It has just crossed. It has just crossed. Suppose if I slightly make it lesser, I can just make sure that it is. Oh, it's slightly bit difficult. Can you see it's exactly almost on the melt axis? So whatever that we have solved here using root survey can also be seen in your root locus. Can you see what is this value here? Is it almost 8 points? Because the value of it has become already 74. So that's why it has. Okay, let me just see. Can I able to see crossing zero? This will not give me that value. No, this won't give me. So it doesn't have that. Okay, maximum. No, let me just try to find out. I won't get this. Okay, I don't have that zero crossing position here. Okay, this is for some other purpose. Okay. Can you just see here as I just keep on moving somewhere here? I can't just zoom this also. Okay, fine. Using 20 sim, you can able to see the movement of poles like this. Now, can you able to now visualize? So maybe in the previous case, maybe 2 days before, so we were changing the value of k and we were seeing okay how the poles were moving. How the poles were moving here. Of course, here how many poles are there? You have only two poles. No, here in this problem, you have only two. If the value of k is equal to 0, it's at -2, -3. As the value of k is keep on varying, so it will just they will come and collide and move on the move. Of course, you can see here for the value of k is equal to 1 and 10. Can you see this was real part is same, only imaginary part is keep on changing. That also you can visualize. That also you can visualize. So I just want to know the mood of the class. Okay, is this is fine? Okay, how to edit the parameters? Okay, let me just go back here. Where is that? It's here. It's here. I can edit the parameters here. I can edit. So you can edit poles and zeros. So we have edited poles. There are zeros. You are locating them, and then let the root locus gain be 1. Go for it. Then go for uh, pole zero plot. you'll get it. And of course, you can say root locus. Suppose if you don't want to see root locus, this is just the pole positions. Then you can see the root locus here. This is a plot of root locus, how it goes. Can you see here? For k is equal to 70, the poles are there on the mesh axis. Correct? The poles are on the mesh axis. If the value of k is more than 70, more than 70, is the system unstable? Why? Why? See here, those two closed loop poles are this arrow and this dot. The other one is here. Other one is here. If you further increase, so this will be keep going to infinity. So its ultimate point is infinity. This will go to minus infinity, and this will reach this zero. This will reach this zero. Correct? Let me just know from the class. Okay, is this fine? Could you able to understand? Okay, what is actually happening here? So we are trying to demonstrate for the given problem here. So you have been given a transfer function so and so. For the transfer function, this was the transfer function given. You are asked to find the value of k for the system to be stable. Since it is open loop transfer function, that is GFS into HFS, you are supposed to know the characteristic equation. Characteristic equation is what 1 plus GFS into HFS. Since GFS into HFS is given, we just did 1 plus that is equal to 0. So we could able to get this as our characteristic equation del of S. We actually got it into this standard polynomial, and then we could able to solve it using roots array. We found the value of k has to be greater than, sorry, if it is greater than 70, system is unstable. For system to be stable, what is the value of k? K should be less than 70 for system to be stable. Correct? So that's what we are trying to prove it over here. So that's what we are trying to prove it over here. So let me just also show you, maybe let me just demonstrate for this. Can I do it for this? So now I have a pole at -2 and -3. There are no zeros. Correct? So I'll go back to this and I will, there is, this is at -2. -3 is already there. Let me delete this. I don't have a zero here. Let me delete this also. Let me say, okay. Let me see poles and zeros. Can you see here? This is one pole at -2, other pole at -3. Can you see this is how the poles will move as you change the value of k? When k is equal to 0, when k is equal to 0, see here, when k is equal to 0, where are the poles? Can you see this x values -2, -3? If it increases, can you see they are coming closer? They are coming closer. Will they break? They will break. Can you see this is there is a line here and there is a line here. So they are exactly the midpoint of -2 and -3. So that is -2.5. Correct? See that? Fine. I think maybe on that day you people might have not given the roots properly. Why it is minus half? It's actually -2.5, no? Oh, if it is -2 and -3, this is actually -1.5. Sorry. Let me see what is that I have written. So this should be -2.5. Where is this? This would have been exactly -2.5. So this maybe people can just take it out. Where is that? This root cannot be minus half. It should be -2.5. -2.5. You can see now we can able to rectify the issues here, because roots cannot be at minus half, because you have one pole at minus 2 and one pole at minus 3. It will be exactly midpoint of these two. So mid of 2 and minus 2 and minus 3 is minus 2.5. So this is minus 2. Maybe on that day I didn't observe this, but I said that again, this is exactly the real part will remain the same. Real part will always remain the same. So that is seen here also. Can you see here, real part is always remaining same here. Can you see this is minus 2 point for whatever the value of k. Once it becomes complex, it's always minus 2.5. Minus 2.5. Correct? Okay. So then just take up one more problem and try to see. Okay, one more interesting one, something like this. G of s into h of s is equal to k into s plus 1 divided by s into s minus 1 into s plus 6. Find the value of k greater than 0 for a stable system. For system to be stable, find the value of k which is greater than 0. So what I'm looking at is, I'm looking at 1 plus g of s into h of s equal to 0, which is now s into s minus 1 into s plus 6 plus k into s plus 1 equal to 0, which is now s square minus s into s plus 6 plus ks plus k, s cube plus 6s square minus s square minus 6s plus ks plus k. Correct? So do I end up with s cube plus 5s square plus 6, okay, k minus 6s plus k equal to 0. Then shall we solve for this? S cube s square, is it 1 k minus 6 5 k s power 1 is 5 into k minus 6 minus k by 5, then it is 0, then it is k. Correct? Is it actually okay? If this becomes, if you're making this 0, then this is k margin minus 6 minus k margin divided by 5 equal to 0. Is it actually 4k is equal to 30? K margin is equal to 7.5. For values of k, when does system is stable? If it is greater than 7.5, it will be negative, no? K has to be less than 7.5 for system to be stable. You can see this is slightly different. The value of k is more than 7. If the value of k is no, k has to be less than 7.5. When it will be stable? Okay, k has 7.5 for system to be stable. Correct? If it is less than 7 points, what happens? Why? Two sign changes will happen. Correct? Shall we see how the poles are looking like now initially? Is it like this? Is it at origin? Is it at +1, -1, -6? Correct? Then actually what happens here is, so this is very interesting to see. Let us see here. You can see the shape of the root locus. Okay, let me edit this. Where are poles? One of the pole is at origin. Correct? Where is the other one? Other one is at, okay, not it's at +1. It's at +1, and the other one is at -6. Correct? Hey. Is that fine? Then this is done. Then let me go for 0. 0 is at -1. Correct? Apply. Okay. See the poles to plot. See here? Interesting. Shall I move the poles or shall I increase the value of k? Okay. Is it fine now? See now. This is at, okay, what to do? The same position, same location. Maybe it is windy, that's why. Okay. See now, as I increase the value of k, can you observe that the arrow is keep moving? Can you see how many are there? One, two to the right, one is to the left. The value of k is less than 7.5. How many poles are there to the right? Those two are these two. See here, this one and this one. Suppose if I further increase, can you see they will break here and they will come to left side? See here, are they coming towards left? This will happen at 7.5. They are on the image axis. Can you see the k value? Can you see it's 7.24? It is still to the right. Can you see here? They are on to left. See here, 7.6. At exactly 7.5, they are on the image axis. Anything more than that? System is stable. System is stable. Will this give you more visualization into the pole position and as the value of k changes, why the poles are going like this? The poles are actually initially on the right hand side. If the value of k exceeds 7.5, they come to left side and system is stable. So what is the answer for this now? The answer for this problem is if the value of k is more than 7.5, system is stable. So k greater than 7.5 stable, k less than 7.5 unstable, k equal to 7.5 oscillate. If it is oscillated, what is the frequency of oscillation? Here you can see this will be 5s square plus k margin is equal to 0. Then s is equal to minus 7.5 by 5, of course under root of it. Is it actually plus or minus j? 1 point 1 point 1.22 radian per second. So that's what you can see here also. If the value of k is 7.5, can you see that it's almost there? 1.24. This is almost 0. Almost 0 means that x value is almost 0. Y value is 1.24. This is j. This is j 1.24. Correct? This is how we can do it. And let me just give the introduction for next problem, and I'll ask you to just solve. Okay, maybe after the test we're going to see this. Okay, let me just see the mood of the class. How they are? How many of you are there with me or not? Okay, could you able to appreciate the 20 sim? Just say yes, no. Just say yes, no. I'm just looking for your chat box. So as fast you say yes, no, that fast the class will get over. Okay, just make it. Okay, this 20 sim is okay, free downloadable. So there's an open source. You can simply download. Only thing is that you have to just go to insert submodel linear system. So you can just edit the things. Let me just write this problem. The problem is, let's just write it here. Let's see. Yeah, just make it. So the equation is s cube plus 3 into k plus 1 s square plus 7k plus 5 into s plus 4k plus 7 equal to 0. This is the equation what I have. It is s cube plus 3 into k plus 1 s square plus of 5k plus, sorry, 7k plus 5 into s plus of 4k plus 7 equal to 0. Now the question is, determine the range of values of k. Determine the range of values of k such that the characteristic equation given here, the characteristic equation given here has roots more negative than s is equal to minus 1. As roots more negative than minus 1. What is the meaning of this here? How many roots are there here in this? 3, correct? So you can just intuitively think of something like this. Can I say this is S plane, this is S plane, and this is 0, and this is minus 1? So now what it says is there are actually 3 poles here. There are actually 3 poles here. So we know that, okay, as we saw in the 20 sim, as the value of k changes, roots of keep moving. Correct? Roots are keep moving. What they are asking is you find the value of k, you find the value of k, you find the value of k such that roots are more negative than minus 1. That means roots should lie here. Root should not come to this side. Here you can see anything to the left of S plane is stable, but they want to be more cautious. They don't want to come close to 0. They want to ensure that they are here only, because they know that this is the unstable, this is the oscillator condition. They don't want to even cross minus 1, because as the value of k increases, it will come to here and then it will go unstable. It assume that it is somewhere here and it will come here and then finally go to right hand side. They want to take a caution that for a value of k where the roots are always more negative than minus 1, that can be found by replacing all these s by s minus 1. Replace all s by s minus 1. You rewrite the characteristic equation, find the value of k, then that will be the solution. Replace all by s minus 1. Then you'll get a new characteristic equation. Then this minus 1 will become the origin. minus 1 as origin. When you get minus 1 as the origin, you find k margin. That k margin will become k is equal to minus 1. That k margin will become the value of s, which happens to be minus 1. It's gone, it's gone, it's gone, it's gone. Let me just see why it has gone. Okay, it's here. The intention here is, of course, the procedure here is replace s by s minus 1. You find the value of k margin. That k margin becomes not for making the system critically stable. It will make the system to have its roots at minus 1 as its real part. Anything value of k less than that will be more negative than minus 1. Anything more than the value of that k margin will become less than minus 1. Less than minus 1. Yeah, we shall just see that problem in the next class. Okay, then all the best for your test. Hope okay you have enough time to read the things. Do I need to take one more promising letter from each one of you for all the courses, not only for my courses? Hopefully, okay. I think if you have learned a lesson from your third semester, there is no need of such letters. If you want to still continue the same results, have to repeat means you're free to do whatever you want. Thank you so much.